Hey folks, our little worksheet, I'll call it worksheet 8.1. So we're using our familiar salmon, mean of 20, standard deviation of 4, okay. And then they say if the sample size is 9, what is the mean of the X bars and what is the standard error of the mean? So you may recall in a previous lecture today, I said that the mu of the X bars is just mu, and the sigma of the X bars is just sigma over root n. Okay, so we kind of did this over here also, where we talked about the X bars all clustering around the mean. So I probably should have said that the mean of the X bars is just mu. But I did say that previously. So here's our formulas, if you like formulas. Okay. So the mean of the X bars, so the average length of a salmon is 20, standard deviation of 4 inches. So the mean of the X bars, so sample size of 9, and you keep taking samples of size 9 and look at the X bar. Oh, it's 20.5, it's 21, it's 19.5, it's 19.8, it's 20.3. They keep clustering around the mu. So the mean of the X bars is just the mu, which happens to be 20. Too easy? So getting 20 is easy. The question is, does it make sense? Okay, the standard deviation of the X bars. Okay, so the standard deviation depends on how many we're sampling. Oh, we're sampling 9 at a time. Okay, so that formula we had is just, it's the standard deviation divided by the square root of n. So the standard deviation is 4 divided by the square root of 9. So that's 4 over 3, which is 1.333, repeating. So far, so good. So this is my answer, and this is my answer. So mathematically, they're pretty easy to come up with. But conceptually, does it make sense? The X bars, the average length of a group of 9 salmon, is always going to cluster around the mean. Okay. And then our standard deviation is always going to depend on our sample size. So the standard deviation is always going to get smaller depending on how many things we sample. Oh, so that's why I'm dividing it by how many things I sample. I'm dividing the standard deviation by the square root of how many things I sample. Aha. Okay, so the next one should be pretty straightforward. We're just changing the sample size to 17. Okay, so the mean of the X bars is just the mean, which is 20. Easy. And the standard deviation of the X bars is just going to be sigma over root n, which is just 4 over the square root of 17, which is, got to ask my calculator. So what I would do on my calculator is, I'm not sure, let me try something. Does this help? 4, oh, my other calculator works better for this. Let's see. So I'm just going to do 4 divided by root 17. Let's see. Batteries are low. That's not good. Clear. 4 divided by square root is in, it's above that button, so I got to press the blue button first. Square root of 17. My 17 is underneath the square root symbol, so my calculator is kind of fancy. You might have to use parentheses on yours. Let me scroll over to get out of there, hit enter, and I get about 0.97014, so I'll just call it 0.97. I'll just call it 0.9701. 0.9701. Okay. Hope that made sense.